All right, good morning. This is KAP for January the 26th, Wednesday. But this is a warm-up. There's like 2 questions, and the second question has like 2 parts. Pause and then play when you are ready. All right, so when we find or write an equation for any problem, we're looking for 2 things. We're looking for our
rate of change,
and we're looking for our y-intercept. Very good. Okay, and we'll plug that into an equation. What's that parent equation, that template that we talked about? Let's hear it. Very good. Okay, so we are looking for y equals mx plus b. Usually the first thing we find is our rate of change. Brenda, how do I find that rate of change?
So you get the change of the y,
yes.
Change of the x.
Very good. And what did you find in your change in y?
So it's -7.
-7. Very good, because it's getting more negative, you're losing 7. What was your change in x?
1.
Adding 1. Very good. And you said to find that rate of change, we put what over what?
Y over x.
The change in y over the change in x. And so that's going to be?
-7
Over
1.
Which class simplifies down to? -7. So if we already missed that, just try and remember that's what we talked about yesterday. Okay, that is correct. -7 is my slope. That is my rate of change. So I'm going to go ahead and plug that into my equation. Y equals -7x. Now what I can do is I can use a point and see if it works. Isabella, what point do you want to use? Doesn't matter which one, just pick one of the points. Which point do you want? Oh, no, not down there, up here. So we're going to plug in 2 and see if we get -12. So if I did -7 times 2, class, does that give me -12? Uh-oh, so we need to either add or subtract something. What do we need to add or subtract? Now be careful here, Samantha.
We have to subtract 2.
Not quite. Etta? You have to add 2, okay? Because -7 times 2 is -14. And remember, with negative, yeah, Miss Lytle's tricky. It's going to be +2. Okay, it's going to be +2. Yes, sir.
Before you do the +2, is it okay if you put like y equals x parentheses -7 +2?
Yes. Yeah, it's the same thing, but again, the grammar, Miss Lytle always likes to have her number, again, that's called my coefficient. I like the number before the leg. That's how I will correct it, but technically it is correct for 6th grade math. Okay? So again, that final equation we determined was y equals -7x plus 2. Now, if the plus or minus thing doesn't work for you, again, you can always find your y-intercept on your table by just working backwards. I'm going to erase this because it's a little cluttered, okay? We had said, like, oh, every single time you're adding 1 here, we were subtracting 7. Adding 1, subtracting 7. If I wanted to find my y-intercept, that's where it hits the y-axis. That means my x value is 0, okay? So if going by 1, I'm going to do the same thing, okay? It would be -7. If I'm working backwards, I could think of it as adding 7, and that would give me a y value of 2. So it's another way to find that +2, that +2. Okay? Just a review of yesterday. Okay, the next problem was an equation. Mr. Williamson said that the equation for this graph in the picture was y equals -1/2x plus 2. Is he correct, and how do you know? Okay? What did you say, Surya? Or Shrieker? I'm so sorry. I'm a horrible teacher. Anyway.
He's incorrect.
Incorrect?
Yeah.
Because?
Because if you plug in the point 1 and 1, 2 for like the dot.
1, 2 is not on this graph. I like what you're saying. Okay, so like this point right here, if I plug in that point, that coordinate would be
0, 1, 0.
1, 0. If you plugged in that point, what would happen?
It would be
not correct, right? Yeah, if I plugged in 1, if I did 1/2 or -1/2 of 1 plus 2, what's that going to equal? -1/2 times 1. negative half plus 2 gives me,
1.5.
it gives you 1.5. Oh, okay, it's 1.5, but that doesn't match, correct? Okay, so let's break down the equation and see if we can identify which part is not correct. Okay, remember in each equation there's like the slope and there's the y-intercept. Visually, I can usually check the y-intercept pretty quickly. It says it's positive 2. Do we agree with that y-intercept?
Yeah.
Yes, because it's going through that, it's hitting at positive 2. So probably what's wrong is the multiplier, the rate of change, the slope. So let's figure out what happened and see if we can fix this mistake. Okay, so if I look at a graph, I can do the change y, change x, or I could do the rise over the run, right?
Yeah.
Okay, what is the rise? Remember, this one's a special one. My rise is negative 2 over my run of 1. What probably happened right there? If we did, what's the mistake? Yeah.
They put x over y.
Yeah, they just split the letters, okay? It's a simple mistake that people make, just be careful. Okay? Again, when we, just to reiterate, when we find the rate of change, we put the change in y over the change in x, or you can think of it as the rise over the run. In that graph, the rise, the change up and down, was negative 2. The run was over 1. That would simplify to negative 2. They flipped it around. They put run over rise, or they're changing x over their changing y, which gives you a completely different number. Oh, okay. It's little details, but they make a big change. Are you good with that now?
Yeah.
All right. Let's go ahead and go over homework. Mine's a little sketchy, so if you think you're right, but the equation doesn't match, let us know. It didn't copy very well, apparently. But yeah. At home, I'm just looking up right now. Let's look at that. The equation should be, you could have just written x plus 1.5, but you needed to go over how I got that. Sorry, my numbers, oh, it is number 9. That's what you said. Okay. So I noticed that the y-intercept is at 0 and 1.5, so we're good with that y-intercept? Yes, okay, but we need to figure out that rate of change, okay? Your points might have been different, but I'm just going to do over the ones that I have on my board. And it went from 1.5, the change up and down. It went from 1.5 to 6.5. That is a change in 5 points. It went 5 full points, even though it's halfway. If I counted 1, 2, 3, 4, 5, it'd be a 5 rise, and it ran 5 as well. 5 divided by 5 is 1. And so that rate of change of 1, you don't have to write that one, but you can write that one. That's what it is. Yes.
Number 4.
Number 4.
Or 7.
7. Sorry, I guess my numbers are off. So they found the rate of change. It was adding 1 each time on the y and plus 2 on the x. So that'd be 1/2. And then again, Miss Liva will typically find out what I need to add or subtract. So if I put in like 7, if I did 1/2 of 7, that gives me 3.5, but I need to get to 4.5. So I would add. Okay. Again, you could work backwards as well. So I see that this is going up by 2, but if I wanted to get back to 0, I need to take half of a jump. So half of a jump of 1 would be 0.5, so that would take me down to 1, if that makes any sense. Anything else? All right, moving on to today's lesson. It's really going to be pretty quick and simple because y'all are rock solid on this, though you might not feel like it, you actually are. And we're just going to look at how we would take a word problem and write our y equals x plus b from there. It's actually pretty straightforward. Again, your slope or your rate of change is just your multiplier, and then your y-intercept is like your starting point. So, for example, like if we think about our gym memberships, remember how there was like a monthly fee plus every time you work out? That monthly fee is like an initial fee, it's like a starting fee. That's going to be like your y-intercept because it's your starting point, and then you go up and down from there. So I'm going to do literally one with y'all, and then I'll go from there. So a police officer writes an average of 45 tickets per hour, and this one has already written 145 tickets. Write an equation that can be used to find y, the number of tickets he will write in X hours. The names don't matter, so sorry about that. Okay, so we need to determine the rate of change, the y-intercept, and we'll plug that into that y equals x plus c. So again, my rate of change is like my multiplier. So let's look and read what do we see in there that would be a multiplier. Class?
45
45 because it says
per hour.
per hour. Okay, that rate of change is going to be 45. That's his rate at which he writes the tickets. Okay, that y-intercept is like our constant. It's always going to be there. It's our starting point in this case. Yes. 145 because that's our starting point. Even if he had no tickets, like it had been 0 hours, he's already written. He started at 145. Or yeah, he's already written 145. Man writes a lot of tickets. Lots of people see it in his county. Okay, and I'll just plug that into my equation. Okay, so again, my template email, or I keep saying email, y equals mx plus v. Let's replace the letters with the numbers that we have. Who wants to write that equation? Brian, let's hear it.
Write the equation using y equals 45x plus 145.
Plus 145. Very good. All right, go ahead and do the next two. Ready, set, go. On your own. Or with the table order. Ready to go.
Number 3.
Well, yeah, so on number 3, what was different about it? Or what words made me change something? Yes.
Coupon.
Coupon means we need to
Minus.
subtract. We need to minus. On number 2, this is the same thing if I did r equals 369h plus 145. When I change the order of addition, does it change the math? No. Okay, but that's not the case always. So on the next 3 problems, I'll go ahead and let you finish the page, but be aware there are going to be some subtraction problems. Does the order in subtraction matter?
Yeah.
Does the order in subtraction matter? Is 4 minus 1 the same as 1 minus 4? No, because this is 3. This is negative 3. Those are 2 different numbers. Okay, so finish the page, but be aware. All right, let's start looking at these. We're on number 4, right?
Number 4, yeah.
Number 4, volunteer for the equation. Oh, sorry. Well, T equals 4.50 m, not 450.
Yeah.
That would be ridiculous. I'm sorry. Plus 235. Y'all agree?
Yeah.
Yes. Number 5. Okay, gotta be careful, Etta.
T equals 657 minus 145.
Very good. So T equals 657 minus 145 n. Now let's pause and reflect on this one. This one has to be written like this. But let's talk about why. Okay? In this problem, we're talking about a bank account and then paying each month for a service. Do we agree with that? Okay? When I'm looking at T, the amount in his bank account, let's think about what's going to be happening. Am I going to be adding to my bank account or losing money from my bank account? I'm going to be losing. So that is why my rate of change in this problem is negative, because it's subtractive, but it's also negative because I'm constantly losing an amount. Okay? I'm going to be losing an amount at the same rate every single time. I also have it in this order. I have the 657 first because that's my starting rate, and with the subtraction, I'm going to be subtracting away from it. Okay? Technically, but I don't think many of y'all would do this. Technically, you could also write it as T equals negative 145 m plus 657. Technically, that is the same way, but I don't think a lot of y'all wrote that the same way. Okay? Because it's still that negative rate. We're losing money at a rate of $145 per month. Okay? This is probably the more make sensible way for you guys. Questions on that one? Yes.
Oh, wait, no.
Okay. Number 6 is something similar. Let's see what we got. Volunteers.
Oh, wait, no.
So for me, I got B equals 12x -12m plus 612.
Yes, and then probably again, the more makes sensible way for y'all was probably V is equal to 615 minus 12m. Because we're starting with the 615, and then withdrawing means to take away. To say bye-bye to the money. Bye.
No.
Thank you. Come back soon. I love you. All right, so what we're gonna do next is not in your packet, and hopefully we're gonna have fun. At home, it's really not, well, I don't know if you can do this at home. So probably just use it inside of the packet for the rest of the work, and check your key on Canvas and see it.